Mysterious plasma bubbles have appeared over the pyramids. What's going on? Have aliens now activated the Stargate? Be sure to stay until the end, because we will not only clarify what these plasma bubbles are about, but also what it all has to do with space. Welcome, everyone. Plasma bubbles over the pyramids. Sounds like the beginning of a really bad science fiction movie, right? But don't worry, no one has to call Brendan Fraser to make another sequel of The Mummy. Reality is once again much more exciting than any Hollywood fantasy. Before we dive into the depths of plasma physics, why not leave a subscription for the channel? My big goal is to get to 100,000 subscribers, and I'm not that far off. You'll never miss another exciting science video, and you can help me a lot with that. Thanks a lot, guys!
But now, what exactly have Chinese scientists discovered?
Using a special radar called LARID, which stands for Low Latitude Long Range Ionospheric Radar, they observed huge bubbles of plasma over the pyramids and the Midway Islands in the Pacific. And by huge, I mean really huge. These bubbles can reach several hundred kilometers in diameter.
Now I can already hear the first among you. Aha, plasma pyramids, that must have something to do with aliens. Let's take a closer look at this. These plasma bubbles are a phenomenon in the upper Earth's atmosphere.
More precisely in the ionosphere. The ionosphere is a layer that extends from about 60 to 1,000 kilometers in height. Here, the high-energy radiation from the sun causes atoms to be ionized. Electrons are thus wrenched from them. The result is a soup of charged particles that we call plasma.
I always have to think about blood plasma. I financed my student life for years with plasma donations. But in this case, there are no drained blood plasma from my veins swirling around, but rather charged particles.
The bubbles that have been discovered are called equatorial plasma bubbles, or EPBs. They usually form near the equator after sunset, when areas of lower plasma density form. These then rise like bubbles in a lava lamp and can spread over long distances. The science journalist Darren Orth from Popular Mechanics describes it this way. These well-known space weather anomalies are called equatorial plasma bubbles and occur in the region of the Earth's atmosphere known as the ionosphere. Here, the sun's UV light separates electrons from atoms, forming a diffuse layer of ions that extends from 50 to 400 miles above the surface. And how did the Chinese researchers discover these gigantic plasma bubbles? The LARID radar emits strong electromagnetic waves that are reflected by the ionosphere. When these waves hit a plasma bubble, the reflected signal is altered. The scientists can measure these changes and draw conclusions about the structure of the ionosphere. It's a bit like using a giant echo sounder to examine the upper atmosphere. Dr. Gokyu Lee, one of the lead researchers, explains the process as follows. LARID uses antennas and transmitters to send high-frequency electromagnetic waves into the upper atmosphere, or more precisely into the ionosphere, and to study their behavior.
Now you might be asking yourselves, that's all well and good, but why should I care? I don't even have a pyramid in my garden. The answer is that these plasma clouds can have significant impacts on our daily lives. They disrupt radio communication and satellite-based systems. Imagine you are just watching your favorite YouTube channel, mine, and suddenly the connection drops. One of these plasma clouds could be to blame.
One of these plasma bubbles could be to blame, so research into these phenomena is not only exciting for scientists, but also has practical significance. The better we understand how these bubbles form and behave, the better we can adapt our communication systems to them. And the LARID radar is a super important tool for this, and just imagine the sheer scale of this discovery. The LARID radar can detect plasma bubbles at a distance of up to 9,600 kilometers. The researchers were able to observe bubbles over the Pacific and Africa at the same time. The results show that EPB irregularities with ranges of up to 7,000 and 9,500 kilometers were observed by the east and west beams of LARID.
This is truly impressive and opens up entirely new possibilities for the exploration of the upper atmosphere. And now it gets really exciting because, interestingly, the observed plasma bubbles occurred during a geomagnetic storm.
Such storms occur when the sun hurls particularly active and large quantities of charged particles at the Earth. These particles interact with the Earth's magnetic field and can also create auroras. We've even seen them over Europe in the last few weeks. Let me know in the comments below if you have seen the auroras.
And this also promotes the formation of plasma bubbles. The researchers were able to observe how the plasma bubbles formed in different directions, at different times. Some occurred after sunset.
Others even just before sunrise. And this shows how complex the processes in the upper atmosphere are. Dr. Gocho Lee sums it up: the results provide important insights for the future development of a low-latitude over-the-horizon radar network, which could consist of 3 to 4 over-the-horizon radars and have the capability to detect global EPBs in real time.
And researchers believe that with just 3 or 4 such radar systems, the formation of plasma bubbles could be monitored worldwide in real time. Imagine a global early warning system for disturbances in the upper atmosphere. This could really be crucial in improving the reliability of our communication, satellite, and navigation systems. The involved scientist, Dr. Ai Hu, emphasizes the importance of this research for future developments.
The successful observation of EPB irregularities from the Pacific to the African sectors by LARID demonstrates the possibility of monitoring the complex longitudinal variations of EPBs over a large longitudinal variation of 140 degrees or more with an OAT radar, even during geomagnetic disturbances. So it's important to realize that these plasma bubbles are not just an interesting scientific phenomenon, but can actually have practical implications. They can cause interference with satellite communications and even affect GPS signals. In a world that is increasingly dependent on satellite technology, a better understanding and more accurate prediction of these phenomena could be invaluable. The discovery also shows how advanced our upper atmosphere research technology has become. Just a few decades ago, making such detailed observations over such long distances would have been absolutely unthinkable.
The LARID system is truly an impressive example of how far we have come in atmospheric research. However, one important question remains. What does this have to do with the Egyptian pyramids? And was the Stargate opened? The Egyptian pyramids served in this case as a geographical reference point.
The Chinese researchers discovered the plasma bubbles over this region in Egypt. However, the causes of their formation are not in the pyramids, but in the atmosphere and in space. It's a shame, actually. It would have been pretty cool if Ra had landed his pyramid ship like in Stargate.
But the true explanation and history of the research is actually even more exciting, because how crazy is it that they were able to make this observation from a distance of several thousand kilometers? And this research could not only help us better understand our own atmosphere, but also provide insights into the atmosphere of other planets. Who knows? Perhaps this knowledge will one day help us in exoplanet research, as such plasma bubbles certainly also exist on alien planets with atmospheres. Exoplasma bubbles on an alien planet. I can already see the headline in front of me. And if you don't want to miss it, when the time comes, feel free to leave a subscription now. And now, let's travel directly to the aliens.
Because there is incredible news in alien research. Some scientists say we are on the verge of discovering extraterrestrial life through megastructures. If you are ready for first contact, then click on the video in the upper right corner where I've explained everything about it. And if you want to support my work, please also take a look at the other videos. Every click helps me a lot. Otherwise, I'd say see you in the next video. Take care, guys.